What's up, guys? Quinn with 74 Weld, joined by with Eric today. Let me start that over. I don't have brain capacity today.
You want me to start it off?
Sure.
What's up, YouTube? We're here back again, here with Quinn Poles, owner, founder, CEO of 74 Weld, and we're here to talk about Jeep portals today.
All right, that works. Yeah, I mean, we just keep rolling with that.
Yeah.
So today, on all of these, we'll have kind of a little outline in front of us. We're not staring down at a table, I promise. We have a list of agenda.
Yeah.
So the whole point of today's video is to kind of dive into the evolutionary process of our Jeep portal. This was the first platform that we started on, and we'll kind of talk about why a portal and our concept for Jeep. We'll talk about the first design iteration, our thrash to get this thing in a prototype stage, ready for King of the Hammers, just to show. We'll talk about testing. We'll talk about failure. We'll talk about our second design iteration, how that came to be, more testing, then moving to production, and finally, who this product is for. And when we touch base on who this product is for, I'll be the first to admit that I don't believe that the Jeep product is for every Jeeper. And I do inherently think that there are shortcomings to a portal on a Jeep if you want to do specific things. And we'll dive into that topic in detail kind of at the end.
So why did you want to do a bolt-on portal in the first place?
So I started making this stuff, not the Jeep stuff, but portals in general, and diving into that in 2010, made the first stuff in 2011. And it kind of goes back to my background. I initially got into off-roading right after 2002, 2001, 2, 3. Made a trip super early on up to Rubicon and was just absolutely hooked. And then, you know, living in San Diego, Southern California, Johnson Valley's 3 hours away. And so that kind of became my stomping ground. And I saw just the ridiculous benefit to a portal in that style of wheeling. So if you're dealing with big rocks and trying to navigate tough trails, it's just inherent that, like, what I kind of tell people is all you have to do is wheel with a portal rig once and you'll understand why we like the product. So I said for a long time that you could never bolt a portal onto a vehicle. You have to build the vehicle around a portal. And part of that was we started with 2-gear stuff, which reverses the rotation. If you have one gear spinning one way and only have a bottom gear mesh to it, each time a gear goes and meshes with another gear, it reverses rotation. And that's why we eventually ended up with a 4-gear bolt-on. So let's jump back to, you don't bolt a portal onto a vehicle, you build a vehicle around that. I felt that way for a good solid 7 years until we dove into designing a portal for 4-gear specifically for a race application. And that went through several different iterations and ended up being fairly successful on the first real prototype that we did. It did some initial design, changes, but we released that and it worked right out of the box. And I started to see that, okay, maybe I could scale this stuff down a bit. And so, the why on this is a gear reduction at the wheel gives you that lift and a re-gear, and it just gives you that ground clearance. And if you could package it in a way where it's not ridiculously wide and crazy tall, I think it, at the time I said, I think it can actually work. And so then it becomes, you have all these design constraints. Can you make it work? And so I guess today we'll dive a bit more into the evolution of answering that question, can we do it? But from a why standpoint, there's just no substitute for ground clearance. If you're not hitting rocks that you're trying to drive over, you're not getting stuck. So I guess initially we'll dive into our first iteration.
Yeah.
And this is something I've wanted to talk about. I think that a lot of companies don't talk about design iterations and how you end up. They just magically end up at the product that we're
here's
selling.
The product, yeah.
That's typically not the product life cycle phase.
No.
And so we'll kind of discuss a bit about that. So
1.19 gear set.
So this is a 1.19 gear set, and the way you determine the gear reduction is number of teeth divided by number of teeth.
Yeah.
And that'll give you a reduction. This was, what was the drop on this?
This one was just about 3.5.
3.5.
Yeah.
So this is a 3.5 inch lift portal, and when I say 3.5, I mean from the center of your top gear to the center of your bottom gear is 3.5 inches. And this, like all of our stuff, integrated a unit bearing into it. I knew right off the bat that we wanted to do a unit bearing because in a bolt-on application, if you're not compatible with ABS, you just don't have a product, or you have a product that there's no way I would ever sell it. I don't think you can ever convince somebody who goes out and buys a brand new vehicle, hey, just ignore the fact that you're going to have an ABS light on. That's not a product.
Yeah. A lot of modern vehicles won't let you ignore it either.
Right. So integrating a wheel speed sensor into that was just one of those key design parameters that were absolutely, it's just a deal breaker. Either you tackle that and integrate it, or you don't have a product.
Yeah. So, and why 1.19 specifically?
So I've made portals. The original Unimog stuff was like 2-to-1, a little deeper than that. We did a 1.63 and a 1.45 in race, and on this, I didn't want much reduction because all we want to do is accommodate for the larger tire size. And so if you take, let's just assume you go out and you buy a Rubicon, they come with like what, a 32-inch tire?
Yeah, yeah.
So if you want to go from a 32 to a 40, what is that percentage gain? It's 20% roughly. Yeah. So we knew that we wanted to be about 20% and just accommodate for a tire size. And so your gear reduction would come in this, and it would essentially put you right back to stock. So the transmission is not overspinning. You're not, you're not at 4,000 RPM at 60 miles an hour. If you tried to put a 1.8 to 2 gear reduction in this, you'd effectively be looking at like a 7.5 to 8-to-1 final drive equivalent on your rig and pinion. That's just a deal breaker right out of the bat. So all we wanted to do was accommodate, give you the ability to run a larger tire, and getting extra gear reduction. We can talk about how that has pros and cons, but we had specific goals, which is bolt this on, don't have to re-gear, get some ground clearance. And initially, I didn't even want 3.5 inches. I only wanted a 3-inch lift.
Yeah.
And we ran a bunch of numbers on gear strength calculation, and we just couldn't get there. Or we couldn't get to a number that I was comfortable with. I see other portal applications out there, and they are a lot of lift. Like, for example, there's stuff that comes out of Europe that it's 130 millimeters?
Yeah.
So 5.118 inches of lift. I think that's way too much. Like I said, on our current iteration, we're just under 4 inches. I'll be the first one to admit I wish that we were 3 inches of lift, not 4. But we'll talk about why it's not going to happen. And the reason I didn't want a ton of portal lift is, like, I've got my 392 behind us, and it's a bone stock suspension, stock coils. I've changed out other stuff, but it's effectively stock ride height, and I clear 40s no problem. In a perfect world, I would like to have a portal plus a couple inches of lift and to be able to run 40s. And that's just not really feasible on the Jeep platform. Unless you like your vehicle to be really tall, which I don't. So, Eric, dive into the first design cycle.
Yeah.
So this is October 2021 to December 2021.
Yeah, it was a pretty aggressive time frame that we set out for. You know, we kind of laid out the parameters of what we were trying to do in early October, and we were shooting for having vehicles by King of the Hammers, so first week of February in 2022. And so, you know, we had our basically gear set up, and then we go, all right, well, what axle are we going to put this on? That was another big decision that we had.
Right.
And you know, rather than designing an entire axle to swap out, we ended up designing around the stock axle housing. For a couple of reasons. One, everyone has one, so you can bolt it on. Two, there's a lot of aftermarket upgrades off of the stock platform. So like, for example, JL44 front, you can go to Dynatrac, you can go to Curry, you can go to TerraFlex, you can go to Ultimate Dana 44. You know, if you really want a better housing, they're out there already.
Well, and I don't know that, I think that most people watching this don't know your background. Where did you work before you ended up here?
I was at Dynatrac previously.
Yeah, so Eric has a lot of experience in axles, that manufacturing process, and brought a lot of that here, which was really a key component in making this successful.
Yeah, I was pretty pumped to take on this project, not gonna lie.
Okay, so keep going.
So, you know, one of the first things kind of Quinn already mentioned, you know, he was talking about gear strength calculations. Then we go into load calculations, looking at our bearing package. So that's kind of the first step is, can we package gear teeth and bearings into this box right here? And then also the width box, because width gain was another big concern that we were looking at. We didn't want to go plus 5 inches per side. And a lot of that has to do with gear width and bearing width in there as well.
Right. So I would say that the most difficult part of a portal is actually the bearing package. It's not the gear package. That subsequently, well, I won't jump too far ahead. That statement came to bite us in the ass a little bit. But,
a little bit.
But bearings, speccing a bearing that can handle the loads that you want in this application is actually very challenging. The information's all out there. It's just, we just had to be willing to dive into the deep end of the pool and come up with something that worked. So,
definitely. So, so we came up with a package that we thought was looking pretty good. I mean, when you're looking at bearing strength, housing strength, any kind of drivetrain strength, power transmission through the drivetrain, you can look at it two ways. One, power coming from the engine down through the train to the wheel, or you can look at it from the wheel in. So, and usually the wheel is going to be a lower load because you only get so much traction per wheel. So if you're looking at just a regular street driven application, you can say, all right, well, in the rear, the worst case is you're going up a hill with a certain grade, so you're gonna have weight transfer to the back. You look at how much weight is on that rear wheel, what coefficient of friction you know you have. The beautiful thing about off-road is now you have wheels getting bound up, you have undercuts, you have all kinds of things that aren't necessarily, you know, on paper and everything.
Well,
so
I guess this is a tangent that's kind of worth talking about briefly. If you look at and just do straight math on this vehicle, I think we determined that a 392 with the gear reductions from transmission, transfer case, rear axle, and our portal, which is not much of a gear reduction, we were at a torque load at the rear axle of about 25,000 pounds.
Yeah, it was a lot.
And to put that in perspective, I did the quick math. I spent a fair amount of time trying to figure out, like, are these numbers actually realistic? Because
Yeah.
25,000 pounds is, to me, is completely unrealistic. Under no circumstance are you ever going to actually see that.
Yeah.
Because the rear Dana 44 shaft, I think, is rated at like 3,000 pounds?
I don't know off the top of my head, but I mean, that sounds
it was
reasonable.
3 to 4.
Yeah, 5,000 foot-pounds is kind of an industry standard for like 35
So-
spline stuff.
So then, how do you get from 25,000 pounds to 5,000? Let's
Yeah.
just call it. And I looked at a bunch of different, like, there's a lot of factors that go involved that become involved in this, which is like, how much torque can you actually put down before your tire slips?
Yeah.
And then, if you hold that tire like in an undercut,
Yeah.
where's that torque going to go? And so I actually looked at and talked with Ray Fields, who owns Dugan's Racing Engines, as well as Rancho Drivetrain. Ray's been a staple in off-road racing and been building engines for trophy truck guys for 30 years probably. And we talked a lot, and I kind of went down the road of how does a dyno actually calculate? And where's this gap? Because if the math says it can put out 25,000 pounds, but the axle shaft snaps at 5,000, and we're being conservative on
Yeah.
that, it's going to actually probably break less
Yeah.
than that.
I think the best number we had was 12,000 from that field test.
Where's that gap? And why is it that you're not actually putting 25,000 pounds to the wheel? And we came up with 10 different reasons, and then we kind of shrugged our shoulders and realized that engine management software,
Yeah.
I think, plays a large factor in this as well, because that computer on that motor is just not going to let that happen.
Yeah.
But there's parasitic loss through drivetrain components. There's torsion as something twists that absorbs energy. There's just so many factors that play in. So I remember back in, it was 2008, and I was on the lake bed with the Tin Benders. This was back when Pirate 4x4 was like the place to be. So there was a Tin Benders rally where the Tin Benders were a local wheeling group. Their home was Johnson Valley. And a guy by the name of Bobby Long, who was well known in the Toyota world, brought out this axle braking machine. And so it was essentially a chain-driven gear sprocket setup with a hydraulic actuator attached. And he could measure both torque load as well as degrees of rotation. And he sat there, this was like on a weekend, and this machine was put inside of, maybe it was 1 inch thick acrylic, so it's essentially bulletproof glass. And he sat there and he broke all of these, probably a half dozen different axle shafts.
Yeah.
And went through and broke a 44, a 60, a Yukon axle, different materials, his own stuff. He owned a company called Longfield Super Joints. Any Toyota guys out there, you'll absolutely know Bobby Long. He passed away a couple years ago. Actually, it's longer than that. But I got to a roadblock where I said that there's just too many factors for us to calculate what our intended torque load needs to be able to handle. And then it dawned on me one night that, oh my God, I remember Bobby Long on the lake bed broke all these shafts.
Yeah.
And the data was still there. I did a little digging and found and this is practical application.
Yeah.
There's no substitute for this. Where did the stock 44 break? Where did the aftermarket 4340 44 shaft break? Where did the Toyota shaft break? Where did the 60 shaft break? And these were both, he did it both in a double splined application, short and long, and then also a U-joint application. And this is really where we based our engineering off of, because as we dove into straight mathematical numbers, we kept hitting roadblocks that we knew, like, look, I get that the math is correct, but something's not.
Yeah, we're gonna blow up everything.
And no matter what we do, we're always gonna blow up everything. And we were doing this after we already had our race product in trophy trucks, in Ultra 4s, and it was living.
Yeah.
And so we typed in those numbers, and in every single circumstance, the gear set and the bearing package exploded on paper.
Yeah.
And we're going, dude, this doesn't, we're missing something in the math. And essentially what we're missing is flex of the chassis, torsion, dissipation through axle shafts, tires flexing, bolts flexing. So this comes down to an engineering concept that these 3D modeling programs allow you to do these days called finite element analysis.
Yeah.
And when you dive into FEA and try to analyze parts, your data out is only going to be as good as your data in.
Yeah.
And if you can't allocate for how much that bolt is going to stretch and how much flex you get out of the sidewall tire and all of these variables, then it's going to spit out a number that says 25,000 pounds. And we go, okay, well, we know that that's not true.
Yeah.
What is true? And if you look at a modern trophy truck, these are $1 million vehicles that run 1,000 horsepower naturally aspirated engines that don't have any torque management software.
Yeah.
They're going to put down about 16,000 foot-pounds of torque to the wheel max. So you're going to sit here and tell me that my 392 makes more torque to the wheel than, say, Luke McMillan's Mason all-wheel drive. Get out of here. I mean, those guys run 2 3/8 diameter 300M axle shafts, and they still break them sometimes.
Yeah.
We're running an 1 3/8. There's no way. So that's kind of the little background to segue into some of the engineering constraints and some of the engineering hurdles that we had to get through.
Yeah, we did.
So we settled on a number.
We settled on a number after a lot of like weeks of analysis.
Yeah,
We settled on some numbers and we said, let's go for it.
Yep.
And so we have our gear and bearing package, and now we can finally get to making housings, things like that.
Right.
So, I guess back to width, we decided to integrate our gearbox into the knuckle to save a little bit of width.
Yeah,
So
so
that,
every portal that had been built prior to the stuff that we did, they would essentially bolt a portal onto a knuckle.
yeah.
And the problem with that is, just from a packaging constraint, you're never going to, it's always going to be, in my opinion, way too wide. So you'll never see us make a portal that bolts onto your stock knuckle.
Yeah.
It has nothing to do with the strength of the stock knuckle, and while I can argue that the stock knuckles are not strong enough, which they're not, that's not the reason that we don't do that. We don't do that because we don't want a 5-inch wide portal. One of our absolute painstaking, most important design constraints that we had from day one was this thing needs to be as narrow as possible.
Yeah.
But at the end of the day, what you're stuck with is a bearing, a gear, and a bearing. And you got to put that stuff somewhere,
Yeah.
and then you still have to have material around it. And lo and behold, we come out at 3.5 inches. It's just, these are the design constraints.
Yeah.
All right, keep going.
Yeah. All right. So we're rolling on that unit bearing. So we ended up going with a unit bearing based off of, say, a 99 to 04 Super Duty.
Too stupid to get this thing in.
So I think
Don't pay any attention.
it's worth noting that because we get a lot of comments like, why didn't you go 05 plus? Because yeah, that's a really, really good bearing. But that
Can't
again,
package it.
yeah, packaging again. So in order to install these things, you need access to this upper gear to plug in a shaft and retain it. The 05 plus unit bearing comes like up to here, so there's no way
Yeah.
to do that. And it actually ended up being too narrow of a bearing, so then your wheel ends up coming
Right.
into here. We couldn't package brakes around it. So again, once the analysis is done, I guess the two things left really are packaging
Yep.
and then making it manufacturable is the other thing. So
And that's a challenge.
that is a challenge. So, I mean, that's part of why, like, this is the first knuckle. You can see it's very geometric, a lot of flats. And a lot of that was going back, two reasons. One, going back and forth with our programmer saying, all right, we can put it in a 5-axis and just plane it. But then also long term, we always wanted to go into mass production. So casting's always been a thought. And with a design like this, there's minimal rework required in order to draft it for casting.
Yeah, so casting or forging for that matter would require angles so that it can release from a mold.
Yeah.
And when we did this, we actually were intending to potentially go to castings.
Yeah.
We're always a fluid shop in the sense that designs and, well, goals are floating. And I had looked into castings for quite a while. And I would say, 6 months ago, at least, more than that, probably a year ago, we decided we don't want to do castings. We want to do forgings.
Yeah.
And we'll dive in a little. We'll talk about castings and forgings and future of this stuff in a forged product some other day.
Yeah.
That's a topic in and of itself.
Yeah. So then the other design consideration is actually being able to assemble it onto the vehicle.
Yeah.
That's a whole nother thing. So in the rear, I mean, JL is great in the rear because JL Rubicon, it's just pretty much a flat flange.
Yep.
So you can just bolt it right on.
And you get that bearing pilot. So when we show you the rear, I get comments from time to time that people go, oh, you're going to break those wheels or the studs off. So we run 4 studs in the backer plate on this. And people would say, oh, you're going to break those studs. There's actually no load on the studs. So our portal registers into that back bearing cup.
Yeah.
And so the load is carried by this aluminum housing, not by the studs. We actually are constrained on the Toyota stuff to a 3/8 diameter stud. But all that stud is doing is gluing the portal to the housing. All of the shear load, like if you jump it or slam into things, the shear load's carried by the aluminum, not by the stud.
Yeah. I mean, we'll get into the King of the Hammers EMC stuff later, but they were running 3/8 studs on the back of theirs too. So that just goes to your point. So but yeah, and then in the front, that was another challenge on Jeep because ideally you have a sealed portal box that you put on the vehicle, but ball joints is an issue because now you have to have a shaft and 2 ball joints and navigate that whole thing on there.
That's not going to happen.
Yeah. So my first assembly procedure, which I did on my Jeep, and it was the dumbest thing, was I had my shaft disassembled, and then I would, so I'd have the stub shaft plugged into this guy, shimmy it on there with the long shaft in there already.
Without a U-joint.
Yeah, and then I would assemble the U-joint on the vehicle, and it was a nightmare. But it hasn't broken yet. It's the same shaft, so it's still good. So I must not have dropped a needle or anything. So.
And then brake packaging.
Yeah, brake packaging. So that's always a difficult part with portals as well.
Yeah, so I never wanted to have to make somebody buy a different caliper. Our goal also in when we talk about all these constraints is I always want to use absolutely as many OE components as possible. We covered why we won't reuse the OE knuckle. It's a packaging constraint thing. We care more about width and strength, and you'd add width and you sacrifice strength if you go with your factory knuckle in any application. Because keep in mind that a portal, if it adds 3.5 inches of width, it's essentially a 3.5 inch wide wheel spacer, which is a bad idea. Now it doesn't crush your scrub radius because you're you're dropping down as well. But it just was something that we went and said, no way, we're doing our own knuckle. We want to reuse factory brakes any way possible, and the factory calipers, albeit they're not the best, you already own them, and they're fairly large. So from a design standpoint, I would say the Jeep was significantly harder than designing a race portal, because with the race stuff, you kind of don't have any of these constraints.
Yeah, you can.
It's all custom. It's actually a lot easier. A lot easier.
Yeah. I do want to circle back to the knuckle installation just because I said
Oh.
our procedure was dumb. I think it's much better now.
Yeah, so our procedure now is essentially your front portal will come, you separate it in half, you put the knuckle on, and then the portal slides in place.
Yeah.
It registers with bearings and dowel pins. It pops together. It's
Yeah.
relatively easy.
Yeah.
We do say that it's a 2-day install. I've done plenty of installs in a day. I actually had an opportunity. I flew out to Mopar to do an install for them and showed up to, it's not my shop, it's not my tools. I didn't ship anything there, hoping that they had all the tools we needed, and they had 65%. They had most of the tools.
Yeah.
But just me by myself working in a shop that's not mine, I did the install start to finish in a day and flew back to California the next day.
Yeah.
So it's just something that you want to take your time on and do it right. And so, it might take 2 days,
Yeah.
but it's not the end of the world.
Yeah. And it's not, I mean, there's not a lot of cutting, welding, all that stuff.
There's no welding,
yeah.
period.
Yeah, we wanted it to be bolt on. You could do this in your driveway if you want to.
Yes.
If you're mechanically inclined.
Uh-huh.
So again, back to the timeline. So October through early December, we're designing. We're trying to get something by the end of January. We
Yep.
release all these parts into the shop.
Yeah.
That's a pretty aggressive time frame to make.
Yeah,
Yeah,
so
obviously.
I mean, I guess the good thing for us is we are a machine shop. So it doesn't mean that I just have equipment sitting with idle with nothing to do, waiting for us to bring our own work in the house. We're a job shop as well. We do work for all different types of customers, but given the fact that we do design and manufacturing in-house, it gives us this flexibility to, for lack of a better term, ramrod shit through the shop
Yeah.
when we need it done right away.
Yeah.
I mean, that does happen from time to time when we see something that we can improve on. We're not sending it out for quote and then waiting for it to come back. And sometimes, I mean, a typical lead time of a machine shop, 4 to 6 weeks.
Yeah.
There's just last week, we decided to make a design change on something. And so this is for a product that we hadn't shipped yet. We changed something. The very next morning, we had those parts built.
Yeah.
So it is really beneficial being able to control that mode of production, and it gives us the ability to quickly adapt.
Yeah.
So leading up to KOH.
Yeah. So, and I mean, at this time, we're still going through all the supply chain issues, which, we're not making every single part. We're trying to purchase what we can. So
We make everything with the exception of cutting the teeth
Yeah.
on the gear. It's easily done by, there's shops that all they do is cut gears. So we do all the lathe work, we do all the blanking of everything, and then we send it up to them. So there are definitely, that's, I guess, the main outsourced component.
Yeah. Yeah. Well, so everything inside of the box is basically pretty well controlled
Yeah.
in-house. One of the things, though, was actually brakes, and I guess it's just kind of to your point that we can ram stuff through if necessary.
Yeah.
We finally got all the parts ready like the Friday before Hammers, and then we realized we don't have the front brake calipers for my Jeep, the JK, because we wanted to do JT brakes on it. And so in a morning, made a new caliper bracket.
Yeah.
Dylan made it. We Jimmy rigged some stuff together and got that thing rolling. But basically, that was a weekend thrash before King of the Hammers
Yeah.
to get everything together, and it actually worked. We made it, so that was good.
Yeah, and that was really our first test.
Yeah.
Now, let me be clear, we were not racing King of the Hammers
No,
on this.
no, this was to go to the expo.
Just drive out, put it at our booth.
Yeah.
We successfully drove from San Diego to Hammers. This was the first road test that we ever did with this stuff,
Yeah,
and had no issues.
yeah,
I was hoping to have my 392 then, but it was stuck in a rail yard. So I didn't get it till after KOH. So then
Yeah.
we had a next big thrash, which was to get all of the JL stuff done so we could go out to Easter Jeep and really test there.
Yeah, yeah.
And this is where I think it's worth. Well, should we dive into Easter Jeep testing?
Yeah, might as well. I mean, pretty much between Hammers and Easter Jeep, we're building this one with the 1.19 stuff.
Yeah.
I'm daily driving on the 1.19 stuff.
And we're logging miles on
yeah.
it, and everything's good.
Yeah,
So we go out to Easter Jeep, and that's where everything went from good to really bad.
yeah,
So I was with a couple friends on Moab Rim, and driving up Moab Rim, and you get through a couple turns and you're overlooking the river, and you come up to a first waterfall ledge, and I get up on the ledge, and it's a little off camber, and I give it a little bit of gas, but at this point I'm still driving very gingerly on the vehicle. I'm not trying to push it, I'm not jumping, I'm not bouncing on the thing. And I roll up and I hear a pop. And I go to roll backwards just to kind of check things out, and passenger rear wheel just locks up. And so luckily I'm with just a couple friends, and we jack the vehicle kind of on its side, get the wheel in the air, and I open up the portal box and 1,000 pieces fall out.
yeah.
And I'm obviously pretty bummed, and I was distraught at that point because I knew that I was probably driving that vehicle at 20%, and so like something failed. So I basically gut the gears out of it. I put it back together, and I turn around and we drive back to camp, or drive back to the condo that we're staying at, and we have spare parts, so I rebuild the whole thing.
Yeah.
And we're discussing like what failed, why, and I think I see exactly what failed. So we're talking about all this, and I go out the next day, and I had already run 2 trails before Moab Rim, didn't have any issues. So maybe this is an isolated experience. Maybe this is not really a design issue. And then
Did one more whole day of wheeling between then
Yep.
and then the next.
And then I go out the following, and we're heading up to the hot tubs. And again, I'm in an area, this time driver rear, and the Jeep is getting flexed out, and my head's out the window, and I'm barely creeping forward, and I hear a pop again, and I know exactly what that is. And sure enough, exploded another gear set.
Yeah.
And so now this has happened twice. It's not an isolated experience. It's not. If somebody breaks something once, you have to analyze that, and you kind of have to go, okay, one time's not necessarily an issue.
Yeah.
But if you see the same thing happen in multiple scenarios where I know for a fact I was not pushing this stuff at all, now you have a problem.
Yeah. So one
And-
time is it material, assembly, whatever.
Right. It can be a million different
Yeah.
things. If it's happening over and over again, okay, now you have a problem. So we ended up, did we rebuild it again, or we just gutted it and
We
said
gutted
we're
it.
good?
Yeah,
we're
you
good.
put it
And that
on the
was the
trailer.
last. That was going to be the last day in Moab. Anyways, Eric had driven out to Moab.
Yeah, well, so I wasn't even there for the first break. I'm wrenching
yeah.
on my Jeep because I have all kinds of non-related portal issues. Quinn just sends me a picture, no context, of
yeah.
like pieces of metal on the ground. I'm like, oh crap,
Yeah.
I have to drive this thing 800 miles out there.
Yeah.
So I get out there, then we wheel some more, and then he blows up another one. And I'm
Yeah,
like, I got to
so-
drive this thing home.
I could only imagine you must have been sweating bullets.
Yeah.
He didn't break anything. and granted, yeah, this is a V8, but like
Yeah.
again, where I broke these things, there's no way that it should have broken.
Yeah.
So we came back, and I basically realized 2 things. One, I believe from a philosophical and business standpoint that if you're not failing, you're probably not trying hard enough.
Yeah.
And if you are going to fail, do that shit quickly and then fix it.
Yeah.
Failing over and over is fine as long as you make those major changes and make them fast. Because the reality is, like, even though we're making it in-house, it's extremely expensive.
Yeah.
And, you know, I basically said, okay, I sat everybody down and I said, we've got to fix this on the next go.
Yeah.
And in my head, I knew that we could do 2 more iterations, but
We don't want to do 2.
I don't. So what ended up happening on the failure was on our first design, we did hollow idler gears and put a needle bearing inside of this. And kind of our whole rationale for this was we thought we could package it a little bit smaller. We thought
Yeah.
that we could make everything a little bit more compact.
Yeah.
So this is actually our first idler gear on the first iteration. And here's the culprit. When we did all of our calculations for gear strength, everything looked good.
Yeah.
But these gears were failing at like 20%, and I'm guessing this 20%. I felt that I was not driving the vehicle hard and shit was exploding. What did we miss? Well, it turned out that when you hollow out a gear, now you have a thinner cross section. And I
Yeah.
know this, but when we did our gear strength calculations, we did it based on a solid gear, not a hollow gear.
Yeah. And then we look at bearings and we're trying to get the biggest bearing we can fit in there.
Right.
Because
So
the idler gear is going to have your largest bearing
Yep.
loads out of everything.
So our minimum cross section, and by that I mean from the root of the tooth, so from the very bottom of the tooth to the major diameter of that bearing, was just splitting. And when this splits, there's not a lot of room in the gearbox, and everything goes kaboom very quickly. So it was just one of those, when they go, it's catastrophic.
Yeah.
And you can still learn, I think. You can probably pinpoint what went wrong. So when we came back, we said, okay, we know for a fact that our race stuff and our race design is solid, because at that point, I think we had a year and a half of racing in a trophy truck. And I basically said, okay, we have new design constraints now. We know where the caliper needs to sit. We know we have a 17-inch wheel. We know we want to make it as narrow as possible, but let's put that narrow as possible kind of on the back burner.
Yeah.
And your new design constraints is wheel, knuckle, and brake. What's the largest gear set that we can get in here comfortably?
Yeah.
And it turns out that our new idler gear is the exact same bearing package as our race stuff. So same bearings on either side, same exact tooth profile, and 10% smaller in diameter, which is not much, and 1/8 of an inch narrower. And this is against what we know handles. At the time, the main guy testing with us was a trophy truck guy that had a Dugan's, and I mean a legit Dugan's 900 horsepower big block engine in an all-wheel drive trophy truck. And that he was not having gear problems. So we went from that gear to this gear,
Yeah.
and it's still packaged. And so we went, okay, let's go. And now we went from a 3.5-inch gear center to a 3.88-inch gear center.
Yeah.
It's not what I wanted to do. Like I said, I really wanted to be at 3 inches. But you can't, in my opinion and limited experience on that, I don't think it's doable. And the problem is like, we don't have unlimited resources and unlimited budget.
Yeah.
And so how much money are you willing to put behind your stab in the dark that you can make it work for 3 inches?
I'm sure someone can with
maybe,
whatever
but-
unobtainium.
And it has to be in a package that's manufacturable,
Yeah.
that doesn't cost $1 billion. So we just said, okay, we're going around the race gears and let's do design number 2.
Yeah. So we did that in 6 weeks.
Yeah,
And
so
6 weeks design and manufacture. So from him breaking to it being back on his vehicle with now
right.
this gear set, we were able to do that in 6 weeks.
So that's a complete engineering redesign,
yeah,
new gears, because it's similar to the race stuff, but similar doesn't cut it in gearing. It's got to be precision. It's got to be exact for the application.
yeah,
We went from a 1.19 to a 1.22, but again, we didn't really select 1.22. That's number of teeth divided by number of teeth, and that's just where it comes out.
yeah,
And by going from, you'll see there's a tooth difference on these. This is an 8 diametrical pitch. This is a 6 diametrical pitch. So then our concern in going to this is when you go down in diametrical pitch, you are increasing inherently you are decreasing your contact ratio,
yeah,
and potentially you might have gear noise.
yeah,
And so that was a major concern as well. So we went to this, and thankfully that was a total non-issue.
yeah,
I hear critique from guys who don't know what they're talking about and have never driven on our product,
yeah,
that you will hear gear whine. It's just flat out wrong. You're not going to hear anything over the tire noise itself.
yeah,
Straight cut gears will make noise, but this is spinning at 700 RPM on the freeway. 700 RPM and 5,000 RPM are very different when you're talking about noise out of a gear set.
yeah,
So we go to the 122. We have to give it more lift. I'm not stoked on that, but it's either that or, well, it was just that.
yeah,
I was not going to try to keep the same tooth profile, and I didn't want to make an incremental change. I knew that we had to make a major change because I cannot afford, literally, I couldn't afford financially to take 2 or 3 more hits.
Yeah.
It wasn't happening.
I'm
And
not trying to
luckily-
get fired either. Got to make this work.
Yeah, I mean, that was never.
Sweet.
Well, I don't blame you for this. I mean, you know, Dylan and I were the ones that designed the gear.
Yeah.
If anybody, we would have shit canned his ass.
Nice.
Sorry, dude.
Shout out Dylan for this set.
Yeah. So second design cycle is 6 weeks. Looking back on that, it's pretty damn fast.
Yeah.
Right?
Luckily though, we had a lot of momentum because we had just done this one. Between February and April, we're already thinking like, how can we make this easier to assemble? How can we
Yeah.
make this more manufacturable? So everything that was going to be a pain in the butt to integrate into this one,
Yep.
it actually worked out well because then we could just
mind me.
put it in this one from the jump.
Yeah.
So that was good.
So then we go into testing on this.
Yeah.
And what did we do? Right away, we drove up to Big Bear. It's
Yeah.
kind of the closest mountain to us. And Big Bear's not really hard trails. You know, there's some decent stuff up there. And so we ran all the hard stuff that we could, and everything was fine. And we started to do more testing, did a bunch more miles on it,
Yeah.
0 issues.
Yeah. So side note, I was kind of upset because I just did 9,000 miles on this at $6 gas in
Yeah.
2022. I don't know if you guys remember that, but
Yeah, that was fun.
so
So then we go into what is our current iteration.
yeah,
We put a bunch of miles on it, and we get it in some additional vehicles. We felt
Yeah.
confident enough that, okay, like we're going to put it on more than just our stuff. So there's a couple guys in the industry who, you know, I start working with, and they're out and they get a bunch of wheeling miles on it. I was on this set. I actually ran a couple trails at the Hammers, but the reality is, like, I wasn't gonna push the vehicle hard enough to like really test it because it's a brand new 392, and honestly, I don't want to thrash the thing. But we started to see other people really wheel it. So like
Yeah.
George,
Holy crap.
does he have a YouTube?
He started a YouTube, I want to say,
So
recently.
there's a guy out of Sand Hollow. Sorry, he lives somewhere else, but he's got several Jeeps that Dixie 4-wheel drive takes care of.
Yeah. Is the Curious George livery on a lot of them the red one with Curious
Yeah,
George?
so Bryce at Dixie said, he and I talk, and he goes, hey, I think I've got a guy that wants to buy a set of portals. I said, great. And so this was February 2022?
Yeah. Or 23.
23.
Yeah, 23.
No,
Was it? February 2022 was first King of the Hammers.
Okay.
Yeah.
So I guess it would have been February of this year?
It feels like it's longer than that ago, but.
So George, I get a video. We put portals on
Oh,
this.
that was the Easter Jeep Safari this year. So that was
Oh, that
April.
was. Okay, so we have maybe 15 to 20 sets out before George. No, 25 because of the first run.
Yeah.
So, but I don't get a ton of feedback. I had done plenty of wheeling on mine, but I just felt that I was not willing to push the vehicle hard enough because I'm not one of those guys that's going to go out and thrash on something to try to get clicks on YouTube. Like, that's not me.
Yeah. I'm not going to do it because I only have one car. So I still had a car note too. So.
Yeah, and I'm trailering on a lot of this stuff
Yeah.
because I want to be prepared if I have to tow it back. So I get a text message from Bryce at Dixie 4x4, and no context in it, no nothing, just George loading up the torque converter and launching his brand new 392 on Pritchett Canyon,
Yeah.
and then almost rolling it, and then throwing it in reverse and stomping on the gas, and
Yeah.
you see him literally jump off of this
Yeah.
thing and land. And I'm waiting for the text message string to like continue, like, hey dude, we broke some stuff.
Yeah.
And I'm scrambling to text back, like, is everything okay? Yeah, everything's fine. We're wheeling the shit out of this thing. Like, that's the kind of testing that I wanted to see, but I'm just not willing. I don't want to thrash my 392.
Yeah. George is awesome.
So then around that same time, the guys from Toyota Walnut Creek end up contacting us and say, hey, we have a 4600 vehicle. It's a Toyota 4Runner. We have a Marlin Crawler RCLT kit on it, and we really want to race it on portals for King of the Hammers. So we go back and forth, and I say, okay, and I stipulate on this, we haven't done all of the R&D on the Toyota ABS system at the time.
Yeah.
This was late 2022. They say they don't care about ABS, it's a race car, no issues. So we put that thing on portals, and they go out and start testing. And this was one of the earlier design iterations of this where they had our mistake. They had a snap ring groove inside of the lower stub shaft.
Yeah.
And so they're out for a couple days, they're pre-running and wheeling, and they say, hey, we broke something. So they bring it back to camp. And I made a comment, I said, well, if you broke something, you're gonna drive like 6 inches and the whole thing's gonna lock up on you. And they go, no, it's free spinning. Okay, so you probably just broke a stub. So we get back to camp, and the stub shaft was sheared. And I take one look at it and go, that's our fault.
Yeah.
We'll fix that. So we put them on all brand new stubs, and they go out, they qualify, they race, and 15 miles from the finish, they ended up blowing out their power steering. So we got a bunch of valuable feedback in the sense that, like, that's a 6,500 pound vehicle.
Yeah, it was a big,
and
big
those guys flog that
Yeah.
thing. Causes a stress riser, which can be a fail point.
Yeah. And
But you're getting valuable data from this. If
Yeah.
you're going to break something, you'd much rather break a 35 spline stub than explode a gear. So now we know at that point, or we could make the logical conclusion. I'm always cautious about making a conclusion off of one circumstance.
Yeah.
But we can make the logical conclusion that our gear set is stronger than a 35 spline stub shaft.
Yeah, because it was a standard feature for a stub shaft of that type with the
Right.
99-04 Super Duty, because how you retain it inside of that snout is with the snap ring.
And
So,
that was common. So we go, okay, well, let's just make an incremental improvement and
Yeah.
get that snap ring out of the torsion zone. So we redesigned that
Yeah.
slightly, and we put the snap rings outside the torsion zone.
Yeah.
And so we do that, and we update. And whenever we're doing this kind of stuff, this is where it gets difficult and expensive. When we're doing an update like this, we don't just update our vehicle, we have to update everybody else that's out
Yeah.
there. And we do that. Like, as an early adopter, you're just kind of along for the ride, but when you're in that ride, we just automatically give you, hey, we updated this. Well, what's
Yeah.
there's no charge on it. It's just, this is part of the evolution of a product. Without early adopters, we wouldn't really have, well, I don't think we'd be able to have success. So as part of
Yeah.
that, I just automatically take care of all of those guys. So we changed the stub, and we've had 0 issues since.
Yeah, because we've made several other incremental tweaks, like with
Sure.
the gear snout. So if you're buying our current design, I would argue you're getting an even better gear set than what they ran at King of the Hammers, just based on some of the
yeah, that's a good point.
piloting and things like that. So,
Yeah. So it's kind of I guess the goal of all of these videos that we're going to make is to try to answer the question as to why.
yeah,
And if we can give insight into why we do what we do, I feel that it gives you the ability to kind of look inside of a business and get a sense of how they develop,
yeah,
and then why things are the way they are. And, you know, I see the debate on portals online where people talk about wanting more lift out of them, and they
Yeah.
see that as a benefit, and I cringe and I go, man, like, if only they knew I only wanted 3 inches. Well, this is our
Yeah.
opportunity to give you insight as to what we really wanted to do, where we started, how we got to the product that we are at now, because this is not one of those, well, and then the first time we nailed it.
yeah. That's not going to happen.
But if you nail it the first time, then the question that you're answering is not that fucking difficult.
Yeah.
Like, if you're not struggling, you're not going to progress. If you're or you're just you're tackling something that's not really that hard.
Yeah,
And I'll also say that if I ever look back on something that we did 2 or 3 years ago,
yeah,
and go, that's the best we can do, that's awesome, I should probably do something else. Because it doesn't mean that we're going to always tweak on designs. Once we get set in production, that's that.
I'm going to hold you to that.
I know. Because I always want to improve things. I always want to get better at it.
Yeah.
But I think we're at the point
Yeah.
now. So the gear set that's in this, we know works, V8s, 40s. We're confident in it. We've run
Yeah.
it in Hemi swaps with 6.6s.
Yeah.
Um,
25,000 road miles so far.
yeah,
So-
and a lot of wheeling.
Yeah.
This summer, Eric Miller borrowed my 392 and ran Rubicon while I was in my Tacoma. The summer before that, I ran Rubicon and Fordyce in my Jeep. Well, part of Fordyce. We had to turn around because there was a JK with 2 broken ball joints.
Ooh.
Like splayed out in the trail. We couldn't get around. But we have a lot of wheeling trips in our own vehicles,
Yeah.
plus a lot of other guys out there who are actually pushing it. And so this gear set that we're settled on is the identical gear set that's in both the Tacoma as well as the Bronco. And moving forward, we're pretty much using the same gear set in everything.
Yeah.
So we get I'll be a tester for you guys when we roll out new platforms. And I kind of say we don't really need testers because as we move forward and develop, and we'll probably do what do we think? 4 platforms in 2024?
Sounds good.
So if we do 4 platforms, let's say in 2024, they're going to have the same gear set.
Yeah.
We'll develop a few other things, but as we move through applications, it then comes down to integrate ABS,
Yep.
package brakes,
Yep.
and any other minor constraints that we have for the specific vehicle.
Bolt to the axle, bolt to the
Yeah.
suspension, you know.
And the
whatever.
devil's in the details of
Yeah.
instructions and all the painstaking
Yeah.
stuff.
Yeah, because I mean that's kind of where we're at now with these production platforms, is trying to make it a very clean kit where you get it and you don't have to call us and say, I don't know what these parts are or those parts are. So if you get our instructions, give us critiques.
Yeah.
Tell us what you find is, confusing.
Yeah,
You know.
absolutely. And we post all of that stuff on our website. You don't have to buy our product in order to look at what's entailed in
Yeah.
doing the installation. Part of the point of these videos is to add transparency to things, and in keeping with that fashion, we'll post instructions and details on all of our products
Yeah.
on our website. I don't really care. I don't think we're giving away any secrets. We're giving you information so that you can make an educated decision.
Yeah.
Well, we thank you for taking
Yeah.
the time. Whether you're watching this or put your phone down and listening to it while you drive, our goal on all of this stuff is, again, really to answer the question of why, to give you some insight into our thought process and where our heads are at when we design and develop things. And I think it's cool to tell a story of, like, we didn't nail it the first time.
Yeah.
Because this is one of the issues I have, or the issues that I take with social media these days, is everything is fucking peaches and sunshine, and that's not real life. I mean,
Yeah.
we go through design, painstaking iterations, and how do we get from point A to point B? It's not just magic. It doesn't happen overnight.
Yeah.
And our heads are always in the mindset of, how do we make this better?
Yeah.
And so if we can share that with you, I'm stoked to be able to do that. And until the next one, thanks for watching, and we'll talk to you again soon.